My research is related to the field of augmented telepresence, which is essentially a combination of augmented reality and telepresence. Telepresence, that means remote operation or remote control of industrial machinery, robotic arms, vehicles, things like that. Let's take an extreme example and consider what happens when we need to repair a satellite in orbit. We can send up an automated drone, but for some applications, full automation is not a wise choice. In this case, we could establish a link up to this repair drone that has been sent out. And we present that repair drone's view to an operator that is somewhere on the ground in a control center. But with adding in augmentation like guidelines or example models on where to cut, where to repair, we enable that remote operator to perform their task in a more safe and more precise manner. Currently, we are investigating augmented telepresence interfaces that are not necessarily immersive, but that are closer to the contemporary telepresence interfaces, flat panel views that the operators see in the mining industry in their test systems. With our interfaces and with our mine-like laboratory, where we have placed sensors in a sealed environment that is somewhat similar to an underground mine, we are investigating different interface modalities, and we are testing what effect is there from adding specific augmentations that remove occluding objects from the scene. The purpose and the task that we are currently investigating is how can we improve the operator's awareness of the rock face, of the back wall, or of generic features in the scene that are of interest that they need to spot and detect, and then act on that information. In our test environment, we are testing rendering methods, solutions in terms of programming, in terms of augmentation design, in terms of sensor fusion, that are removing some parts of this machinery from the view to a larger or lesser extent. And we want to use that test system to find out whether there is a significant improvement or not from this modification. In addition, we are also using depth-based image rendering to present new perspectives of that remote scene from only the two camera views that we originally have. By presenting new perspectives, it might be possible to give the operators a better sense, a better understanding of the 3D structure of that remote environment, which again might lead them to make more accurate decisions in their work task.